Добрый день.
Добрый день.
Леня присоединяется. Есть. Так, один момент. I'll call this child of mine. Okay, I called. So, how are you guys?
Fine, thank you.
Good.
Mm.
We were supposed to think about exercise 12 over here in propositional logic. Well, and so actually, in this problem, in this task, we're given four argument forms, abstract logical patterns involving proposition P and Q. Each argument has premises, the assumptions, and the conclusion. The claim that follows over here. Premise, conclusion. And the job is to decide which of these argument forms are valid in propositional logic. So we ask if the premises are true, does the conclusion necessarily have to be true? If yes, we mark it as valid. If not, we mark it as invalid. Okay? So let's go. If, well, the first case, if P is then Q, is it valid or invalid? If P then Q. We're looking over here, number one. If P is given, then Q is a conclusion. Valid or invalid?
Valid.
Valid, of course. Because if P implies Q and P is true, then Q must be true. Okay?
Mhm.
Okay. Now, number two. If Q is given and the conclusion is P, is it valid or invalid? Well, looking over here, the formula is P2Q. Guys, what do you think?
We don't know is the P the only one if P and only P conclude to Q.
Okay, Q is true. Okay, Q is given. The conclusion is P, but the formula is if P is true, then Q is true. So if Q is true, is it necessarily that P is true?
P might be true. Might.
Maybe not. It's not
No, P is true.
Okay. If the grass is wet, does this mean that it rained recently?
Yes.
Not necessarily.
Not necessarily. Maybe, maybe not. There are other reasons why the grass might be wet, right? Maybe we used hose, which is watered the grass. So, if Q is true, it's not necessarily that P is true. And this is the fallacy of affirming the consequent. Okay? This is not valid because Q being true does not guarantee P. Q could be true for other reasons. Okay?
You have just denounced the whole thing called deduction.
All right. Well, we are not talking deduction. We are talking formal logic, right?
Right.
Okay, number 3. Negation of Q is true. Does this mean that negation of P is true? So we're given P to Q. Okay? If P, then Q. And negation of Q is true. One moment. So you should think in terms of negation. If right?
Negation of P is true.
Okay. If negation of Q is given, negation of P is true. So this means if P implies Q and Q is false, because negation of Q, if Q is true, negation of Q is false, right? Then P must be false. Okay, there is no way that Q is false and P is true. Okay? Here's winner. So, if the formula is P implies Q, P to Q, then Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is true. P to Q is false. P to Q is And negation of P is true, then negation of Q is true, then negation of P is true. Okay? Right. Number 4, P to Q. And negation of P, if negation of P, then negation of Q.
Might be true, might be false.
Again, policy of denying the antecedent. Number 2 was the policy of affirming the consequent.
Fallacy?
And mistake.
Oh, like fallacy?
False. Fallacy, yeah. Sorry for my pronunciation. Okay. So fallacy is okay.
Yeah.
Fallacy of affirming the consequent is number 2. And fallacy of denying the antecedent is number 4. So number 2 and number 4. Might be that, might be not. Okay? And if we think that P is it rained, U is the lawn is wet, and number 2 would be the lawn is wet, then might be rain, might be not. Say it in terms of 4. What is negation P here?
It didn't rain.
It didn't rain. What's negation Q?
The lawn is dry.
Yeah. So, if it didn't rain, is it necessarily that the lawn is dry?
No, since we might have used hose.
Indeed. Right. Okay. Okay. So, I guess we discussed this truth table was there, right? If we have this if and only if thing, yeah. We discussed equivalence, contradiction, and tautology. Is that correct? We did that, right? Just remind me. Probably we didn't do equivalence, contradiction, and tautology last time. Yeah, so equivalence. P and double negated P are equivalent. That should be obvious, right? Exercise 13. We're looking at the truth tables. Yeah, we have these truth tables. I actually shared this PDF. And looking at A, P and Q, negation of negated P or negated Q, are they equivalent or not?
Equivalent. Yeah, ну что?
Okay. P and
Equivalent.
can you explain?
Anne and Mary girls are girls, so we cannot say what or Anne or Mary are boy. Is boy.
Guys, one moment. This one is or, right? And this one is and.
Подождите,
Still
вроде
not good.
наоборот было.
One moment. This one is and.
Окей, тогда не
Upper
так.
side is and. Yeah, sorry, my mistake. And this one is or, right? So P or Q. My mistake. Negation of P and negation of Q is double negated P. Sorry. We've got negation of P and negation of Q, right? Negated negation of P and negation of Q equals double negated P or double negated Q. Am I correct? So we sort of multiply this negation, double this negation, and we flip the operator. So we get double negated P or double negated Q, which equals as double negated P equals P and double negated Q equals Q. This gives us P or Q. Yeah, which is the first formula, which means they are logically equivalent. And this transformation of one moment of negation of P and negation of Q, and then we transform it to double negated P and double negated Q, and then sorry, we must flip we must flip the operator. Double negated P or double negated Q. Then we simplified it and we get P or Q. And this is called De Morgan's transformation. It's called De Morgan, трансформация De Morgana. De Morgan's transformation. De Morgan's transformation. Yeah. Okay. Let's look at B. P to Q, negation of P or Q. What do you say? Equivalent or not? P or Q. Yeah. Okay, any answers? What do you say? P to Q, negation of P or Q. Equivalent or not?
Equivalent.
Okay, let's go step by step. First, we start with the conditional. This is conditional. If P, then Q. Okay? False only when P is true and Q is false. In every other case, it's true. Now we can express the same idea as if P then Q, either P is false or Q is true. Okay? So P to Q is false only when P is true and Q is false. Yeah, I'm trying to repeat it myself. This can be rephrased as either P is false or Q is true. Yeah, which is negation P, that's P is false, or Q is true. Okay. So this is another formulation of this if P then Q. Questions? Guys,
Oh,
react
great.
like this is clear. No question. Okay, good. Right. What about not P, not P and Q, not P or not Q? Okay, we're looking at two tables and we have not P and Q, like not P and Q. And the other formula is not P and not Q. Not P or not okay. Or not Q. Not P or not Q. Equivalent or not? Ideas?
Yes, equivalent.
Equivalent, yeah. So first we apply the Morgan's law and we get not P or not Q. And actually this is it, right?
Mhm.
This gives us this formula. So yeah, they are equivalent. They are equivalent. D, P or not Q, not P and not Q. P, sorry, P and not Q. Yeah, the second formula. P or not Q, P and not Q. Okay, we take the second formula and we apply the Morgan's law And we'll get, what do we get if we apply the Morgan's law? Negation of P or double negation Q. All right. So after applying the Morgan's law to the second formula, we get this thing. We added this negation to both parts and we flipped the operator. Right?
Right.
Then we compare. Then we can simplify the double negation. Okay? We simplify the double negation and we get P or negated Q. Okay? And we compare. And we get, yes, they are equivalent. Right. And next, P to Q, negation of Q to negation of P. One moment. Copy the copy. P to Q, negation of Q to negation of P. Equivalent or not? We apply the Morgan's law to P to Q, and what do we get?
Sorry, what is Morgan's law?
Morgan's law is that if we have this negated something with two parts, we add negation to both parts and flip the operation, the operator from N to O, from O to N.
And how do we flip that?
Say it again.
How do we flip that?
No, I mean, okay. One moment. Morgan's law. Negation of P and Q equals is an equivalent of negation of P or negation of Q. This is De Morgan's law. Okay, I mean, this is De Morgan's law for conjunction, for example. Okay, negation, De Morgan's law for disjunction would be same, but with flipped operator. It's like not P and not Q. Just one moment. One moment. De Morgan's transformation, De Morgan's law for disjunction would be negation applied to negation P. One moment. Okay, one moment. I need to think of a formulation of this. De Morgan's law. One moment. We'll get this formulation. Okay. Two forms. De Morgan's law tells us how negation distributes over and or. Okay? When you move a negation inside parentheses, you must flip the operator and operator or. I mean, if it's and, then it becomes or. If it's or, it becomes and. And negate each part, each term. Negation of a conjunction gives us this thing. This is negation of a conjunction. And okay, and negation of a disjunction is this. Okay, these are two Morgan laws, De Morgan's laws. So, again, are we good with that?
Yes.
Yes.
So you might just keep it in mind, or I don't know. I don't know. Repeat. I might make a screenshot. Hello, guys. And send it to WhatsApp. Yeah, for everyone to see. Right? Then I will be able to clear. So the last one, we take this P, if P then Q, P implies Q, P to Q, and negation part would be, well, the second formula would be if not Q, then not P, then we remember that in propositional logic, not Q, meaning if Q is false, then P should be false. Is that correct? Can you see that?
Yes. Yes, it's correct.
If P is false, if Q is false, one moment. If not, one moment. This is called contrapositive. Let me check the explanation because I do not understand it in full. Is there anyone who can explain this contrapositive thing? I understand that it's correct, but I do not understand how to explain it. So, meaning P, if P then Q, and it is the same as not Q, if not Q, then not P. If Q is false, then P is false. Yeah? And if we're talking in rain terms, then if it rains, the lawn is wet. If the ground isn't wet, then it didn't rain. Yeah, if the lawn is dry, then it didn't rain. And this gives us the idea that every conditional is logically equivalent to it's contrapositive. Contrapositive, I'm going to copy this to Telegram. Yeah. Each conditional P to Q is the same as its contrapositive. And this is called contrapositive. Here you are. The contrapositive reverses the direction and negates both parts. This is what the contrapositive is. Yeah. If Q how do we do it with the table? How do we see it in the table? Can you explain? I understand that we should compare. I mean, the second one, the contrapositive, is if Q is false, then P is false. Right? If Q is false, then P is false. How do we agree with the second line? Because Q is false here as well. If we take this table, if Q is false, P might be false or P might be true. I don't understand that. It should go to P to Q over here, probably. Yeah.
I think what in this table only the only Господи, я даже по-русски не знаю, как это объяснить. В общем, мне кажется, что тут все из пи исходит, и только от пи пляшет. Тут нельзя посмотреть на какую-то другую часть и
Да-да-да, это то, что касается P2Q. Да? Вот, если у нас есть P и Q, и таблица P2Q, да? И P2Q fails тогда и только тогда, когда Q fails, а P при этом верное. Во всех остальных случаях оно нам возвращает валидное рассуждение. Валидное, как это по-русски говорить. Да, то есть P2Q fails only when P is true and Q is false. Yeah? P is true and Q is false. In the second line. In the second line over here. Yeah. And contrapositive is if Q is false, then P is false. Which should fail only when P is true and Q is false. So, the line, the table, the truth table for, okay, we've got truth table for P to Q over here. And if we build the truth table for not Q, one moment. Not Q to not P, not Q to not P. If we build the truth table for that, if P is true and Q is true, what do we get? We get true, right? If P is true and Q is true, not Q would be false, not P would be false, false, false gives valid, so it's true, okay? If P is true and Q is false, then it renders false, not valid. If P is false and Q is true, then we get false to true, false to true. And when we have a conditional false to true, it always renders true because it doesn't make sense, okay? So we get true and true. One moment. We get true in the third line because it's this situation false to true. And what do we get in if both P and Q are false? We get true to true, which is true. Okay? So it's the same as P to Q. Okay, guys. Я поняла. I got it. What about you? So, the thing is to draw the truth table for the formula, and then we'll see that it's they're the same. So the formulas are equivalent. Yeah. Right. And the last one. P to P, P or not P. What do you say?
I don't understand what is P2P.
If P, then P. If it rains, then it rains.
Tautology. The
It's
tautology.
tautology.
Yeah.
Yes,
Mhm.
it is. So K, P,
P, not
and
P. That's
P.
true.
Mhm. P or not P, any case, right?
Mm.
It's true, because tautology gives us, if it rains, it rains. It is always true. It's always valid, let's say that. Okay, it's always valid. I mean, if it's false, then it's false. If it's true, then it's true. It's always valid. And P or not P gives us both situations, right? I mean, either true or false. The whole universe of situation. So it's always valid as well. Right. So P2P is always valid. P or not P is always valid. They are equivalent. It's tautology. Thing should be. Right. Now we go on with contradictory formulas. Two formulas are contradictory if and only if for every assignment of values to their variables, their truth values are different. For example, P and not P are contradictory. For each P that is true, not P would be false. For each P that is false, not P would be true. Yeah? Another contradictory pair is P to Q and P and not Q. Right? Now, tautology is also called valid formula, is a formula that is true under every assignment. Whatever data we feed to this formula, it's valid. Okay? And there is the opposite of tautology, which is called a contradiction. Whatever data we feed to the formula, it is false. There is no way to get a true value out of this expression. And this is also called inconsistent or unsatisfiable. Right? It's like a white dog is black. False. Under any dogs. Right. Now we have formulas that are neither valid nor inconsistent. And we'll call them contingent. And we have formulas that are either valid or contingent, which are satisfiable formulas that can yield true. Right? Okay. It is everything about whether we can get the truth value out of the formula or not. So, tautology, we've already saw that. P or not P, tautology. Yeah. And you remember the biconditionals? Biconditional is formulas that use if and only if. Yeah. So, like, it rains if and only if it's not rain. It's not raining. And this is a tautology. Yeah. So when the two expressions are equivalent, if we join them with a biconditional, we get a tautology. So here P is an equivalent of not P, meaning it rains, it's not raining. And if we join those equivalent formulas with a biconditional, just if and only if, we get a tautology. Always true. So, exercise 14. Which of the following are tautologies? Ideas?
I think about C.
Q to P should be not Q or P. One moment. If we okay. Yeah, the tautology in C would be a tautology if the two expressions are equivalent. Are they equivalent? What is the equivalent of P to Q? Oh dear. We did it, right? Like earlier. P to Q not Q to not P, right?
Mhm.
Not Q to not P. Ah, lost. Yeah, not Q to not P. One moment. Not Q to not P, not O. I mean, I'm not sure C works. Guys, what do you say?
Mm.
Wow. Okay, P or Q. Is it a tautology? P is not equivalent.
No, it isn't.
No, it isn't. There is a condition under which P or Q gives us false. It's not always true. Yeah, if P is false and Q is false, then P or Q would be false. So, no, A is not a tautology. Now, what about P to Q and Q to P? We are looking at the table, in which case Q to P would be false. We already did this truth table. Yeah, you remember we did it for a different thing. Let's do it for Q to P. If P is true and Q is true, Q to P gives us what? If P is true and Q is true, true,
Gives us true.
true, gives us true, thank you. If P is true and Q is false,
Also true.
also true, because it's the situation false to true. If P is false and Q is true, what do we get?
False.
False. And false, false, what do we get?
True.
True, perfect. Now, compare it with P to Q.
Not the same.
Not the same. And if we are looking at P to Q or Q to P.
I think that's always going to be true.
If P is true and Q is true, what does it give us?
True.
True. P true, Q false.
Also true, because one of them's true.
Good. P false, Q true.
Also true, because one of them's true.
P false, Q false.
True.
See? This is a tautology.
Мгм.
So B is
М.
a tautology. What about C? P to Q, not Q. P to Q if and only if, not Q and not P. Tautology or not? You check, is there a situation when it gives us false? If P is true and Q is true, P to Q gives us true, okay? Just take your pen and paper and, okay? Not Q or not P gives us false. So if and only if operator gives us false, because the second formula is false. See? And also if P to Q gives us false, if and only if gives us false, because one of the formulas are false. So we've got false values over here. See? It's not a tautology.
Мгм.
Right. What about D? Are there false? Okay. We've got R here, which is, remind me what we called R. Yeah. Over here. Propositional letter R stands for the sentence Geordie consulted Wolf. Yeah, this is difficult. Why did we call it R? Is that just... Probably this is just the third formula, okay? The third propositional letter. Okay? So, we have this. Yeah, here we are. We have P or Q. Yeah. If P or Q, then R. If P or Q, then R. This is our first formula. If P or Q or P, if P then Q or P then R. either one or the other. This is the second formula. And we have this operator if and only if. Tautology or not? Is there a situation when it gives false? This is quite difficult, right? Demands some writing, so I am giving you this screenshot in the chat. Look at it. So, oh, this is if P is true and Q is true, we help. Why do we have R false?
What, huh?
Can you explain me the first line of this table?
The first line? Uh,
Like
okay.
P is true and Q is true.
Uh-huh.
Why R is false?
Uh, hmm. That's the symbol for or, right?
Yeah, this is the symbol of
Um,
P or Q. If P or Q, then R.
mhm.
I
don't know.
All right. Um,
It's probably something to do with the if and only if thing. I don't know.
yeah, why R is, let's ask what R is. Okay. Okay. Right. So the real table looks like, oh dear, didn't copy. One moment. The truth table for P, Q, and R, in fact, looks like this. One moment, I'll share it with Zoom. Yeah, this way, right? course, we must take all possible variations of P, Q, and R. So we have P true, Q true, R true. P true, Q true, R false. And go on. So here in the table, we've got all possible variations. And we must check the formula for truth or false, true or false value, checking all those variations. So we check not 4, but 8 variations. Okay, is this clear? Guys, is it good? Yeah? Right, one moment. So, you've got the table in the chat, so you can look at it, and then you check if P or Q, then R. For the first line, what do we have? Okay. P or Q, then R. For the first line, what do we have? We check 8 lines in the table. P true, Q true, R true. Come on, guys. We got true, right?
Mm-hmm.
P true, Q true, R false. What do we get?
False.
False. Good. P true, Q false, R true.
True.
True. Good. Rina, are you here with us?
Yeah.
Can you help me with this true false thing?
My God.
P true, Q false, R false.
Oh, R is also false?
Yeah.
Says true though. But fine. Uh, then I guess that's false. Cause
False. Right.
yeah.
Yeah, exactly. Okay. Now, what was the next thing? True. P false, Q true, R true.
True.
True. P false, Q false, R true.
False. Or I guess that's actually not necessarily true. Like, I guess it could also be true, so I guess that's also true.
Right. P false, Q false, R false. Check.
That's also true.
Okay. Sorry. I'm starting 1, 2, 3, 4. This is our usual. 4. 5 is P false, Q true, are true.
That's
Yeah,
true.
Now 6. 6. P false, Q true, R false.
That's false.
That's
Wait, hold
false.
on. B true, Q. Yeah, that's true. False, I
P
mean.
false, Q true, R false. Yeah, should be false.
Yeah, that's false.
Yeah. 7. P false, Q false, R true.
That's true.
True. P false, Q false, R false.
True.
True. Right. Because each time when it's false, if conditional gives us true. Oh, sorry. Conditional gives us true. Each time when the premise is false, conditional gives us true. Yeah, that's why 7 and 8 are true. Right. So, these are cases when the first part of our if and only if yeah, these are all the values for the first part of this equation. What did I say? These are the truth values for the first part. Now, let's look at the second part. Second part is P to Q or P to R, right? And we have P to Q or P to R. And we check it again for 8 situations. P true, Q true, R true. What do we get?
Do you want me to answer someone else?
Okay, Sonia?
I don't understand.
Look over here. This is the second part of our formula, of our equation, okay? Yeah? And now we are checking the truth values, looking at the table of truth values, truth table for PQR, and this truth table is in the chart in Telegram, okay? For you to just have something before your hand, before your eyes. All right?
Mm-hmm.
Okay, now let's take the first line. First line gives us P is true, Q is true, R is true. What do we get for the whole expression? P to Q or P to R?
So,
True. We get true. Because for getting true, we need to have one of the parts valid. Okay, true. So either P to Q should give true or P to R should give true. And if all of them true, then one of those parts certainly is true, and this means that operator OR gives us true. Now, P true, Q true, R false.
Peter Q is true, so the disjunction is true.
The disjunction is true. Good. P true, Q false, R true.
True. Be true.
True.
So true.
Yeah. P true, Q false, R false.
P true. Q false. False. False.
False. Good. Now P false, Q whatever, R whatever. Окей. Любое значение для Q и R при P false.
If P false, then all false.
У нас, товарищи, вот этот if оператор, да, всегда дает true, если premise is false. Потому что это тогда не имеет отношения как бы к premise.
Подождите, почему? Я не понимаю.
Мы это в прошлый раз разбирали. Значит, если идет дождь... Так, кто-то что-то написал. Thank you, Win. Yeah, absolutely. Ну, вообще это, мог бы и сказать. Мы в прошлый раз разбирали, что ситуация, когда P, когда у нас есть P to Q, да, если P false, да, то следствие из P всегда будет...
Это, короче, по типу каждая селедка рыба, но не каждая рыба селедка.
Нет.
Типа, если это селедка, то значит это рыба. Если это рыба, это не обязательно значит, что это селедка.
Ну да, это ты объясняешь суть вот этого направления, да, когда у нас одна
Но,
стрелочка. Но, ну да.
ну да, соответственно, если это рыба, но не селедка, это не означает, что когда это селедка, это не обязательно рыба. Это никак к этому просто не относится.
Ну да. Короче, когда у нас премис, вот этот вот первый член, false, у нас возникает ситуация, когда conditional как бы сейчас я в терминах дождя скажу. Значит, если идет дождь, то лужайка мокрая. Да? Теперь рассматриваем ситуацию, когда дождь не идет. Если дождь не
Нет,
прошел,
ну с этим понятно. Я не понимаю, как вот к нашей теперешней формуле это относится.
к нашей теперешней формуле как это относится? Значит, у нас есть P2Q при условии, что P false. Да, мы рассматриваем с 5 по 8, когда P false. Да, с 5 по 8 строки в табличке Truth
Короче,
Table,
ладно,
которая вот
объясняйте
последняя.
дальше. Я все равно, я это с кем-нибудь другим пройду. Не хочу задерживать группу.
Да все
Тем более у
нормально,
нас
мы уже на
кончилось
самом деле
время.
дополнительное время, да. Дополнительное время, я уже даже на русский перешла из этого. Значит, смотрите, P2Q дает нам truth value всегда, если P false. Как раз потому, что если дождя нет, то от этого заключения, если пойдет дождь, то лужайка мокрая, да, оно как бы вне этого заключения оказывается, вне этого, вне этой логики, вне этого логического, вне, я даже не знаю, вне этой ситуации, вот. Поэтому, да, правило, когда у нас P2Q и P false, у нас всегда будет true. Собственно, вся мозголомная штука, да, когда вот это вот не очевидно, она вся идет вот именно из этого, что если P false, если первая часть false, значит conditional дает нам truth value. Вот. Теперь, если у нас формула P2Q or P2R и P false, то обе части
Да,
дадут нам truth value. Все, в результате от 5 до 8 у нас будет truth. Да? Но при этом дальше мы смотрим на всю формулу, объединяем первую и вторую части, и мы понимаем, у нас там оператор if and only if, да, для того, чтобы у нас была тавтология, нам надо, чтобы if and only if оператор всегда выдавал значение правды. Для этого нам нужно, чтобы вот эта таблица, да, вот эти две таблицы, два столбика были одинаковые. Они не одинаковые, потому что у первой формулы больше случаев false. Вот. Соответственно, это не тавтология. Соответственно, это не тавтология. Окей. Так, теперь давайте 15-е упражнение, над ним поразмышляем дома. И в следующий раз мы подводим итоги propositional logic и переходим к предикатной логике. Окей? Окей. Right. Next time. Homework. Exercise. Что там, 15-е, да? Summary of propositional logic. Start of predicate logic. And finish. Thank you to everyone and see you in a week.
Thank you.
Thank you.
Shavuot